All right, so we've been doing arithmetic sequences and series. So today we are going to look at geometric sequences and series. So what did we do when we had an arithmetic sequence as we went from one term to the next? We were either adding or maybe subtracting, right? Which is just adding the opposite. Okay, well, when we have a geometric sequence, we're multiplying. And so a geometric sequence will have a common ratio. And that's what you're multiplying by. So to be able to tell whether a sequence is geometric, I just have to look at the ratio between the terms. So for instance, if I look at 10 compared to 4, and then look at 18 compared to 10, and 28 compared to 18. Basically, I'm taking a term and then dividing it by the term previous to it. And so this would reduce to 5/2. This one reduces to 9/5. This one reduces to 14/9. So these are my ratios. Are they the same? No. So this one is not geometric because it has no common ratio. How about if I look at this one? Does it look like there might be a pattern on this one? What do you guys think's happening on this one? It's being divided by 5, right? Okay, but with geometric sequences, we want to write it as a multiplication because we're going to be using exponents. So basically, if you're multiplying by 5, if you're dividing by 5, that's the same as multiplying by what? Times 1/5, right? So all of these are times 1/5. And so it is geometric. And the ratio is 1/5. So when you see that it's dividing, just take the reciprocal and multiply by that, okay? If it was dividing by 2, that means you're multiplying by 1/2. If it's dividing by 10, you're multiplying by 1/10, okay? And if it's some other, like suppose the ratio turns out to be something like 3/5, how would I find that? You would do like I did on the first one. You would just take the second term, divide it by the first, take the third, divide it by the second, make sure they come out the same, and that's going to be your ratio, okay? All right. So the rule for a geometric sequence is just a sub n equals a sub 1 times r to the n minus 1. Because we're multiplying by r over and over and over again, right? So when you multiply by something over and over again, that's an exponent, right? And the reason that it has to be n minus 1 is I want my first term to come out to be a sub 1. So first of all, you guys are going to want to memorize that. But you can see if I plug in a 1 for n, I've got a sub 1 times r to the 1 minus 1, which is a sub 1 times r to the 0, right? And r to the 0 is 1. So that way it comes out equaling a sub 1. So that's why it has to be n minus 1 rather than just to the n power. Okay? So I'm going to write a rule for the nth term of the sequence, and then I'm going to find a sub 7. So my first sequence is 4, 20, 100, 500. What's happening here? It's being multiplied by 5, right? So that means my ratio is 5. And a sub 1 is right here, right? A sub 1 is just 4. And so I just plug it into the rule up there. A sub n equals 4 times 5 to the n minus 1 power. So how am I going to figure out a sub 7? Plug in a 7, yeah. So 4 times 5 to the 7 minus 1, which is 4 times 5 to the 6th. And that is 15,625. So when I multiply that by 4, I get 62,500. Okay. Questions? All right, let's take a look at this sequence. So this one, I've got 152, negative 76, 38, negative 19. What can we tell about the sign right off the bat? It's going to have to be negative, right? And also, do you think this one's going to be a whole number or a fraction? It's going to be a fraction, yeah. So I can figure out the fraction by just taking any term and dividing it by the term previous. So my ratio, I could take 38 and divide it by negative 76. And if I reduce that down, it's negative 1/2, yeah. So my ratio for that one is negative 1/2. So now I'll let you guys write the rule and figure out what a sub 7 would be. It's going to be a fraction, but don't let that freak you out. All right, so what did you guys get for the rule? Okay, let's write the rule first. So a sub n is going to equal, what was my a sub 1? 152, and my ratio of negative 1/2 to the n minus 1. All right, and then when we plug in the 7, we get negative 1/2 to the 6th power. So what's going to happen to that negative sign? It's just going to go away, right? So I've got 152, and then 2 to the 6th power is 64. And then that will reduce down to 19 over 8. That's right. Okay. So these are pretty straightforward. You're really just plugging it right into the formula to find it. Okay? Questions, though? Okay. All right. All right, so now I'm going to just give you one term that's not the first term, and I'm going to give you the common ratio, and we're going to write the rule. So I know that I can plug in what I know. A sub n is going to equal a sub 1 times my ratio 2 to the n minus 1, right? And they gave me a sub 4. So I can plug this into my equation and work backwards to find out what a sub 1 was. So 12 has to equal a sub 1 times 2 to the 4 minus 1, which is a sub 1 times 2 to the 3rd, right? So that means 12 equals 8 a sub 1, and we divide by 8. And 12 over 8 reduces to 3/2. So my a sub 1 is 3/2. So a sub n equals 3/2 times 2 to the n minus 1 power. Okay. So when you're done writing that down, here's one for you to try. A sub 6 is negative 96, and the ratio is 2. All right, so when you work backwards, you would have found that a sub 1 was negative 3, so when you plug it in, negative 3 times 2 to the n minus 1. All right, so let's think about what's happening here. I've got 6 terms, and I know the 6th one is negative 96. And my ratio is 2, so I'm doubling it every time, right? So could I also just work backwards and figure out what it is? Why not? So all we're doing when we plug it into the equation, the 2 to the 5th, is we're taking a shortcut. But if you forget how to do it, you could always write it out and work backwards. So what's the opposite of multiplying by 2? Dividing by 2. So if I go backwards dividing by 2, I get negative 48, negative 24, negative 12, negative 6, and sure enough, negative 3 is the first term. So that's another way you can do it. If it's not like, the 51st term or something that they give you. Now, if they give you a really high number, you're better off just figuring it out mathematically. But if they give you something that's in the first, 6 terms, it's pretty easy to also work backwards, okay? So that's another option for you guys. All right, so now I'm going to use the same philosophy that I just showed you to figure out when they give me terms that are somewhere in the middle. So I've got a sub 3 of negative 48. I don't know what 4 is or 5, and I know a sub 6 is 3072. And I want to find the rule for the nth term. So if you think about what you're doing, you're multiplying by the ratio every time, right? Times r, times r, times r. So in other words, if I take negative 48 and I multiply it times r 3 times, that's r to the 3rd power, right? That's going to equal 3072. So I can divide that. And I get that r cubed is negative 64. So what's my ratio going to have to be? The cube root of negative 64, right? So if you don't know that off the top of your head, you can figure it out in your calculator. But I imagine you guys are going to start getting comfortable seeing these show up all the time. So the ratio is negative 4. So that means that I was multiplying by negative 4 each time. So can I figure out going the other direction? Yeah, so instead of multiplying by negative 4, I would divide by the ratio, right? So negative 48 divided by negative 4 is positive 12, and then divided by negative 4 is negative 3. And you could fill in the rest going the other way if you wanted to, but you don't have to. So a sub n is going to equal negative 3 times negative 4 to the n minus 1. So using that same technique, I'm going to give you this one and have you figure out the rule if a sub 2 is negative 12 and a sub 4 is negative 3. Okay, so if r squared is 1/4, what does the ratio have to be? 1/2. Could it be a positive or a negative 1/2? It could. It could actually be either one. So it just depends on what your situation is. So if I make r equal to a positive 1/2 and work backwards, what's the opposite of multiplying by 1/2? Timesing it by 2. So I would have negative 24, negative 12, negative 6, negative 3. But if my ratio is a negative 1/2, now I'm going to be multiplying it by negative 2. Negative 12 times negative 2 comes out to a positive 24. And then we'd have negative 12, positive 6, negative 3. So you can see that either one of those is possible because I still get the negative 12 and the negative 3 where they're supposed to be. So you actually have two possible answers for this one. A sub n could equal negative 24 times 1/2 to the n minus 1. And it could also be positive 24 times negative 1/2 to the n minus 1. Okay, so you asked, does that happen a lot? That's going to happen anytime your ratio is squared or to the 4th or the 6th power. Anytime that the number of times you're moving is an even number. So because I was 2 terms apart, it was r squared. If I was 4 terms apart, it would be r to the 4th. So in those situations, it can be positive or negative. Okay, but if it's odd, then it just depends on the sign that you get. Okay? All right, so last thing we'll talk about today is the sum of a finite geometric series. And again, this is just a formula that you memorize and you plug it in. R can't equal 1, because if it did, I'd have a 0 on the bottom. Besides, if the ratio was 1, we would just have the same number over and over and over again. So that wouldn't be much of a sequence. So if I want to find the sum of the geometric series from 1 to 16 of 4 times 3 to the I minus 1 power, I literally just plug the parts in. So a sub 1 is that 4 right there. And my ratio is the 3, so that's going to go where the r's are. And the number of terms I have is that 16 on the top. So the sum of the first 16 terms is 4 times 1 minus 3 to the 16th over 1 minus 3. So this is one you're going to want to use a calculator on because they're really big numbers. The 1 minus 3 to the 16th ends up being negative 43,046,720, and that's being divided by 1 minus 3, which is negative 2. I can reduce that. 2 goes into 4 twice, and the negatives cancel each other out. And so the sum ends up being 86,093,440. Okay. Okay, now in this one, they've kind of thrown you for a loop a little bit because now they started at 0 and 5. So one thing you can do is you can convert it so that it meets the form of the other one. If I add the 1 to the 0 and the 5 and just subtract 1 up on top, I get a new series which would give me the same exact terms. And then I can use these numbers for my equation. Either that, or you can do like we did yesterday. You can realize that 5 minus 0, from 0 to 5, you have to count the 0 also, and there's 6 terms. Either way, you need to realize that there are actually 6 terms, not 5 terms on this one, okay? So the sum of those 6 terms will be 4 times 1 minus 3/2 to the 6th power, not the 5th, over 1 minus 3/2. So it's up to you whether you want to convert it or whether you want to just think about it that there are 6 terms, and the first term is going to be 4 either way, but that's up to you. All right, so if I go through and simplify this now, I get 1 minus 729 over 64. And that comes out to negative 1/2, 1 minus 3/2. So let me go ahead and turn my 1 into a 64 over 64. And simplify it, and I get negative 665 over 64 over negative 1/2. So first thing I'll do is I'll get rid of those negatives since I've got a negative divided by a negative. So whenever we divide by a fraction, that's the same as multiplying by the reciprocal. So to get rid of that compound fraction, I'm going to do 4 times 665 over 64 times the reciprocal 2 over 1. And so 4 times 2 is 8. That goes into 64 8 times. And so you end up with 665 over 8 as your final answer. Okay. Questions? Yes. Okay. Yeah, I'll answer that in just a sec. All right, so that's it for today.